So, good afternoon, everyone, and welcome to this lecture. This is lecture number 7, and we are supposed to complete this electrical devices. We have already covered we have already covered voltmeter and ammeter. Do we remember this? And we had seen question of conversion of voltmeter into ammeter and ammeter into voltmeter. Do we remember that? Yes or no? Do we remember those questions? Yes or no? Do we remember those questions? Yes or no? Okay. I don't know what everyone else is saying. I hope that your answer is a yes. And I need to cover a couple more questions. Okay, this question was done. This question was done. This question was done. Okay, solve this question and do it quickly because we have lost a lot of time and I don't think we have more time with us. So this is the question that is coming on your screens. Let me just adjust this. Okay, coming on your screens now. You see it on your screens. The scale of a galvanometer of resistance 100 ohms contains 25 divisions. It gives a deflection of 1 division on passing a current of 4 into 10 raised to the power minus 4 ampere. The resistance in ohms that must be added to it so that it may become a voltmeter of range 2.5 volt is how much? Everything is given, maybe in some different terms. I hope you are able to sort out how we are going to find it. So I'll give you 2 minutes. Let me know once you get an answer. The options are there. Let me know the correct answer. So have you tried this question? Anyone got any answer? The answer as given is already known. 150 ohms. How are we supposed to do this? Oops, I am writing solution. This was the question. How are we supposed to do this? Anyone? We have to find out the full scale deflection current. How will I get the full scale deflection current? Remember, it is given that there are 25 divisions and one division gives you a current of 4 into 10 raised to the power minus 4. So if I have to find out the full scale deflection current, that will be equal to 4 into 10 raised to the power minus 4 multiplied by 25. So your full scale deflection current will become 10 raised to the power minus 2 amperes. Do we understand this? Now you have to convert a voltmeter, a galvanometer into a voltmeter. The value of the series resistance, if you remember the formula, V by Ig minus Rg. That was the formula. Now you can just put it. 2.5 volt is the range divided by 10 raised to the power minus 2, which is the full scale current, minus 100, and that is your answer. So it is 250 minus 100, and the answer that you are going to get will be 120 ohms. This is how questions may come in your exam. The question on conversion has not come for 1 or 2 years, which I remember. So there is a high probability that this question may come. Do we understand this? Yes or no? Everyone got this? Okay. Okay. Well done. Chalo then. Remember, I'm trying to cover all types of questions that are going to come. Some questions, like the next one which is going to come, may require some of calculation. Do not get stuck with the calculation. I will give you 1 minute. I will give you 1 minute to read the question, try on it, and if you are stuck into calculation, don't worry, you can give the answer in terms of alphanumeric answer. You can call the resistance as R, you can call length as L, and so on. You can give the answer in that way also. So this is the question, a galvanometer whose resistance is 10 ohms. So this is the resistance of the galvanometer, gives a full scale current, Ig is given. The length in meter of a resistance wire whose area of cross section is given. So you can take area as A. That can be used to convert the galvanometer into an ammeter. So basically, this question simply asks you what resistance must be connected to convert a galvanometer into ammeter. Once you get the value of that resistance, you have to find out the length of the wire. You know the relation between resistance and length of the wire. Resistivity is also given, area is also given. So from where I see, this question is a very simple one. I'll give you a minute to think about it and then I will go ahead and solve it. How are we supposed to do this one? It's a straightforward question with a straightforward answer. We have to find out. Let me first write question. We have to find out the resistance that we have to put in the shunt. So we just put the formula of resistance of the shunt. The shunt resistance is given by Ig, full scale current, into Rg divided by I minus Ig. Everything is given to you. You just have to put the values of Ig. Ig is 0.5 ampere. Rg is 50 ohms. And the maximum current that you have to measure is 5 ohms, 5 amperes. You can put this value and get the resistance. Once you get this resistance, once you get this resistance, that must be equal to rho L by A. You know, rho is given to you as this one. The area of cross section is also given to you here. You can calculate the length of the wire. Do we understand this? Yes or no? Okay. Let me now take you to the next question. I hope everyone has noted this down. Everyone understands this? Do not understand this or have not noted it down? What? Right. I'll give you a minute. Once you are done, please let me know. Then let's move ahead and solve this question. These are the types of questions that are going to come in your examination hall, and that is why I'm doing so many of these questions. In the following figure, ammeter and voltmeter reach 2 amps and 120 volt. What is the resistance of the voltmeter? A simple question. And I'll give you 2 minutes to give me the answer. So, how are we going to do this? It is given that the voltage read by the voltmeter, this is the voltmeter. So basically it is saying that the voltage across these 2 points is 120 volt. The current is 2 amps in the line. The current is 2 amps. You have to find out the resistance of the voltmeter. If I call the resistance of the voltmeter as R, this R and this 75 are connected in parallel. So the equivalent resistance between point X and point Y. What is the equivalent resistance between point X and point Y? Equivalent resistance between point X and Y will be 75 R upon 75 plus R. Yes or no? Do we understand this? This is the equivalent resistance between X and Y. If I multiply by the current, I should get the voltage drop. So basically 75 R upon 75 plus R multiplied by the current. Current is given as 2, must be equal to 120 volt. It is as simple as this. Once you understand this, we have done so many questions on this. You will get the value of R, and the answer that is given is 300 ohms. Please note it down. Have you understood this, how this is done? Do we understand this? Yes or no? Yes or no? Okay. Note it down. One last question on this. Everyone has noted this down?
Sure.
Okay. I get some voices. So this is the question that I am looking at. I'll give you 2-3 minutes to solve this. I've seen this type of question come many times in your JEE main as well as advanced. A galvanometer with a scale divided into 100 equal divisions has a current sensitivity of 10 division per milliamp and a voltage sensitivity of 2 division per millivolt. What adoptions are required to use it? What adoption means? What you have to connect to convert it into an emitter of 5 ampere and a voltmeter which can read 1 division per volt. So this question is a simple question but given in an indirect way. I'll give you time to take a deep long breath, take a deep long breath, and then think and solve it and get me the answer. Okay. So how are we supposed to do this one? Please listen to me very carefully and see how this is done. Everything is given, but it is not given directly. It is given indirectly. So how are we going to get this? It is given that it has 100 equal divisions. 100 divisions are there, and the current sensitivity is given as 10 divisions per milliamp. Current sensitivity is 10 divisions per milliamp. So from there, you can actually find out the full scale deflection current. Full scale deflection current means what is the maximum current it can measure. So for 1 milliamp, it has 10 divisions. For 1 milliamp, it has 10 divisions. Total number of divisions are 100. In one to measure 1 milliampere, it needs 10 divisions. So in 100 divisions, how many milliamps it will measure? That will be your full scale current. So your full scale current becomes 10 multiplied by 10. 1 multiplied by 10 multiplied by 1. It becomes 10 milliamps. Do we understand this? Yes or no? Do we understand this?
Sure.
Similarly, the full scale voltage is given. What is the full scale voltage? It is given as 2 divisions per millivolt. That means for 1 millivolt, we have 2 divisions. Total divisions are 100. So how many millivolt we can measure? That becomes 2 1 millivolt can be measured by 2 divisions. We have 100 divisions. So what is the maximum voltage we can measure? It becomes 50 millivolt. Do we understand this, everyone? Yes or no? Once we understand this, I can find the resistance of the galvanometer. It is voltage across the total voltage that it can measure divided by total current. That will give me the galvanometer resistance, and that I am getting as 5 ohms. That is the main part of this question. You get the galvanometer resistance as 5 ohms, and you get the full scale deflection current as 10 milliamps. After this, you can simply find out the value of shunt resistance. What was the formula of shunt resistance? If I remember the formula of shunt resistance, it was Ig into Rg divided by I minus Ig. You can just put the values here. The value of Ig is 10 milliamps. 10 into 10 raised to the power minus 3 into resistance is 5 divided by full scale current is 5 minus 10 milliamps. You may not subtract it. You can just neglect it, and you will get your final answer 10 into 10 raised to the power minus 3. So 0.01 ohms becomes your shunt resistance. Do we understand this? Anyone understands this? Similarly, you can just put the value V, the total voltage it has to measure should be equal to Ig into Rg plus R series. It has to measure 1 division per volt. It has got 100 divisions, so it will have to measure 100 volts. Do we understand this? That is it. Everything is given, bacha, but it is given in just the reverse fashion. So this is 100. 100 will be equal to Ig is 10 milliamps. 10 into 10 raised to the power minus 3 into Rg is 5 ohms plus R series. From here, you can find out the value of R series, and it will come, I think, as 10,000. 10,000, or if you subtract 5 from 10,000, it will come as 9,995 ohms. Everyone understood how I have done this? Yes or no? Huh? You understand this? Okay. Do we understand this? I'll give you 1 minute to note it down. Then let us move ahead and move on to the next topic. Move ahead on to the next topic, and the next topic is very simple: meter bridge. Any idea what a meter bridge is? Meter bridge. So write the next heading: meter bridge. Meter bridge. Anyone heard this term meter bridge? Have you seen it in a lab, physics lab? Have you seen a meter bridge? Yes. Why it is known as meter bridge? Because it is made up of 1 meter wire. So therefore it is known as a meter bridge, because the length of the wire is 1 meter. This works on the principle of balanced Wheatstone bridge. Everyone knows this, yes or no? Balance Wheatstone bridge. Everyone knows this, yes or no?
Sir.
Who is this Pondra and who is this? How come people are entering this? I did not allow anyone. How they are entering? Okay. It is based on the concept of balanced Wheatstone bridge. Do we understand this concept of balanced Wheatstone bridge?
Sir.
Okay. The next thing that you have to remember, that resistance of a wire is equal to rho L by A. So from here I can write the resistance of the wire. If the resistivity remains same, the temperature remains same, resistance of the wire is directly proportional to length. We understand this, yes or no?
Sir.
We understand this, yes or no?
Sir.
So a meter bridge is just based on this principle, these three things. If you remember these three things, you should be doing well. Then there is a small diagram. Now, even a very simple diagram will do, but I will just tell you the systematic diagram of a Wheatstone bridge, and a systematic diagram of a Wheatstone bridge looks like this. This is a schematic diagram of a Wheatstone bridge. This is a schematic diagram of the Wheatstone bridge. Here on the left hand side, bacho, what you see is RB. RB is nothing but a resistance box. Here you know what resistance you are putting. So this is a known resistance. This resistance is a known one. We know how much resistance we are putting here. We know how much resistance we are putting here. And this S is an unknown resistance. Do we understand this?
Sir.
S is an unknown resistance. Do not allow anyone to come inside. Do not allow anyone. I don't know who else are coming inside with the name of KVC and all that. Don't allow anyone. Just throw everyone out. The only people who are concerned to be in the class are there. You are there and the other class is there. No one else comes in this class. Okay. So we have one on the left hand side, we have a known thing. On the right hand side, we have an unknown thing. And this gentleman, the blue gentleman, is known as a jockey. You understand jockey? Just a wire, and you can make connections here and there. Here we have a battery, and normally we have a switch somewhere here. We have a switch. So we put the switch on. We put the switch on, and then we move the jockey along the meter wire. At some point, the deflection in the galvanometer would be 0. You can see this. You can see this galvanometer. The deflection in this galvanometer, or the reading of this galvanometer, will come to 0. That is known as the null point. Do we understand this? Do we understand this? When the reading in the galvanometer is 0, that means no current is passing through this branch. Then we have the condition of valence Wheatstone bridge. Now, when the condition of valence Wheatstone bridge comes, this known resistance divided by the resistance of this half will be equal to the unknown resistance divided by the resistance of this part. Do we understand this? Yes or no? That's it. If I call bacha this resistance as R, we can simply write the equation. Now remember, the resistance of the pink part is directly proportional to the length L, and the resistance of the green part is directly proportional to 100 minus L. How did you get 100 minus L? Because the total length of the wire is 100 centimeters. So if one part is L, the other part becomes 100 minus L. Do we understand this? So we have the very simple equation, and the very simple equation is S, the unknown resistance, divided by R, will be equal to 100 minus L divided by L. So I can write the unknown resistance as 100 minus L by L times R. Do we understand this, or this has gone above our head saying bye bye? Now I'll give you 1 minute. Note this down, and then we can move on to some problems. Once you are done, please raise your hand so that I can move ahead in life. And this is the question taken from your favorite book. Now you might find that the question is written as a potentiometer wire. Potentiometer also does the same thing. Why this one is written as a potentiometer wire? Because this wire is not 1 meter long. Therefore, instead of calling it as a meter bridge, they have called it as a potentiometer. Doesn't matter. The question and the concept remain same. The potentiometer wire AB as shown in the figure is 40 centimeter long. Where should the free end of the galvanometer be connected to AB so that the galvanometer may show zero deflection? Do we understand the question? The only difference between this question and the question that we have done, meter bridge, is that meter bridge has 100 centimeter of wire. This only has 40 centimeter. Will you be able to do this? Yes or no? You have 2 minutes to give me the answer. So how are we going to do this? I hope everyone is looking at this. Yes or no? So let me call this length as X. Then this length becomes 40 minus X. Yes or no? When the galvanometer shows 0, this is the condition of balanced Wheatstone bridge. So I can write this 8 divided by this X will be equal to 12 divided by 40 minus X. Yes or no? That's it. What you have to write, 8 divided by X will be equal to 12 divided by 40 minus X. From here, you should get the value of X. What is the value of X you are getting from here? You're getting the value of X, yes or no? Okay. Anyone can do this, yes or no? Okay, let me give you one more. Remember, again, it is said that it is a potentiometer. Remember, it's only called as a potentiometer because the length of the wire is not 1 meter. So this is the question, and I expect an answer pretty fast. I hope you can give me the answer fast. Okay, so we have an answer again. AD is given as, I think, 30 centimeter. So this is 20 centimeter. And you can see 6 divided by 30 would be equal to R divided by 20. Everyone got this? Yes or no? No, yes. Okay. Okay. Shall we move ahead?
Yes, sir.
The next heading that we are going to write is potentiometer. Now, what is a potentiometer? Well, it's also just like a meter bridge. The only thing is it has a wire which is much large as compared to the meter bridge. And it can do everything that a meter bridge does. It can do more things. It can measure the voltage difference. It can it can compare the EMF of the battery. It can do a lot of things. So what is a potentiometer basically? Potentiometer is a device much like a meter bridge, but it can do a lot of things. Here are some of the things that it can do. It can measure the EMF of a cell. It can be used to compare the EMF of cells. It can also be used to measure the internal resistance of a cell. It can also be used to find the value of unknown resistances if you want. You can also find out the value of unknown resistance. You have seen we have done 2 questions. It was also potentiometer. It can also find the potential difference between 2 points. If we want, we can also find out the potential difference between 2 points. Do we understand this?
Yes, sir.
So this potentiometer can do a lot of stuff. Now, what are the principles on which this potentiometer works, or what are the points to remember? So you can write important points to remember about this potentiometer. The first point that you must remember is that the specific resistance of the potentiometer wire must be very high. Why it must be very high? So that when the temperature changes, the resistivity does not change. One of the principles on which this potentiometer works is resistance is equal to rho L by A, or when rho and A remains constant, rho R is directly proportional to L. Now this formula will only hold when the resistivity of the wire remains constant, and therefore a very necessary condition for potentiometer to work is that the resistivity of the wire should be constant. Do we understand this? Okay, I'll first give you all these points. You just note it down, and then we will go and understand what these points mean. The second point is all the higher potential points, and we will understand those higher potential points should be connected together, and the lower potential point should be connected together. I will make you understand all these points. You just note them down first. Once we understand the circuit, we will be able to understand all these points. Right now, you just note them so that I can move ahead. The third point is the unknown potential difference must be greater than the value of known potential difference. I will tell you what is that value of known potential difference. It must be more than the unknown potential difference. The potential gradient of the wire must remain constant. What is this potential gradient? Just note them down first, and I will tell you all about them once I go through the circuit diagram. Once I go through the circuit diagram, we will be able to understand these things. Why we are writing this before? Because these are the basic principles on which a potentiometer works, that the diameter or the area of cross section should remain constant, the temperature should be constant, or the resistivity must be high, the potential gradient must be constant, the unknown EMF should be less than the known EMF. You will get to know about all these things. Just give me a couple of minutes. First, you note down these points. Now, as soon as we understand these points, we must understand that in a potentiometer, we have 2 types of circuits. The first one is known as the primary circuit. What is the primary circuit of this? It's very simple. It just has a battery, which is a known battery, and it has a wire, and the length of this wire is usually very high. It's not 1 meter, it is much more than 1 meter, and therefore this potentiometer becomes a more sensitive device as compared to a meter bridge, because the length of this wire is very large. So you can see a battery of EMF E and resistance R. This is a known battery or the known source. In your point that you have written, you have seen the known potential difference. This is the known source or the known potential difference. Do we understand this? Yes or no? Now, because of this battery source, a current will flow in the wire, and you can easily write the value of the current that flows in the wire will be equal to E divided by capital R plus small r, where capital R is the resistance of this wire whose length is L. Do we understand this? Yes or no? I'm not able to see you. I hope everything is fine. Okay, so first of all, I find out the current in this wire is E upon R plus R. Now, once I know the current in this wire, I can find VA minus VB, which is the potential drop across the potentiometer wire. That will be simply equal to I multiplied by R. Yes or no? So it will be equal to E upon R plus R multiplied by R. Everyone understands this? Simple things put together. Now, if I divide, oops, wrong color. Now, if I divide this VA minus VB by L, this thing is change in potential divided by length, and this is known as the potential gradient of the wire. dV by dL, change in voltage or voltage drop per unit length, is known as your potential gradient. Whenever you hear the term potential gradient or gradient of anything is always the change in that thing divided by the distance or the length. So dV by dL, that thing is, my dear friend, known as potential gradient. Do we understand this? Potential gradient, and this, as you can see, will be equal to E upon capital R plus small r into R by L. Do we understand this? Yes or no? No or yes? So these are the things that you must remember. This potential gradient should remain constant. Do we understand this? Otherwise, this device will not work. This potential gradient should remain constant. For this to remain constant, your R should remain constant. For R to remain constant, resistivity should remain constant and area should remain constant, and that will explain all those things that we have written. Do we understand this?
Yes, sir.
Have you noted this down? Have you noted this down, bacha?
1 minute, sir.
Okay, let me know once you are done. Now, this is a question that will make you realize everything that you need to know about a potentiometer. This is the primary circuit of the potentiometer given to you. You have a battery of voltage 2 volt and the internal resistance of the battery is 1 ohm. Then you have one more resistor, which is the resistance of the other wire, which is given as 20 ohms. And then you have this blue wire, which is the potentiometer wire, whose length is given as 10 meter and resistance is given as 10 ohms. What things you have to find out are very simple. You have to find out the current in the primary circuit. This is the primary circuit. You have to find out the potential drop across the potentiometer wire. How much is the potential drop? You have to find the potential gradient, potential drop divided by length. And then you have to tell me what is the maximum potential which we can measure across this wire. 4 questions all related to each other. If you understand this, you understand potentiometer. I'll give you 2 minutes to do this. So, can anyone tell me what is the answer for the first one? A. What is the current in the primary circuit? Voltage is 2 divided by total resistance is 1 plus 20 plus 10. Do we understand this? So the current in the circuit is 2 divided by 31. Please raise your hand so that I know. Yes or no? Then for point number B, I can find out VA minus VB. How will I find VA minus VB? I multiply the resistance of the wire by the current. When I multiply the resistance of the wire by the current, I get the answer as 20 by 31. That is VA minus VB. We understand this? The second thing is dV by dL. This dV by dL is nothing but the potential gradient. So this is how much? 20 by 31 divided by 10. So it becomes 2 divided by 31 volt per meter. Yes or no? Do we understand this? Now the last question is, what is the maximum potential that you can measure across the voltmeter? The maximum potential you can measure is the potential drop across the wire AB. So the maximum voltage difference that you can measure will be 20 by 31. Do we understand this?
Sir.
Anyone understands this?
Sir.
Anyone got the answer for this? Yes or no? No or yes?
Yes, sir.
Okay. Anyone, shall I move ahead?
Yes, sir. Done, sir.
So now we can understand how potentiometer can measure potential difference. How potentiometer can measure potential difference. If you understand this, everything is sorted out. So how does a potentiometer measure the potential difference? Now you will have some secondary, some primary circuit. The primary circuit is not shown here. What is shown here is the secondary circuit. So basically, you can find out the current in that circuit. Now, if you connect an unknown voltage here, unknown battery here with a jockey, and when this jockey shows null point or when this jockey shows 0, you understand that there is no current in the section, in this blue section, then that means there is no current. Do we understand this? Yes or no?
Sir.
So then you can find out the value of this V. The value of this V will be nothing but equal to, the value of this V will be nothing but equal to dV by dL. Do you understand the meaning of dV by dL? Yes or no? You can call this
Yes,
dV by
sir.
dL, let us say as x, which is the potential gradient. Potential gradient is x. So you can call this as dV by dL multiplied by this length L that you see here. So you can now just call this dV, the potential drop, as x multiplied by L. Do we understand this? Yes or no? No or yes?
Sir.
We understand this?
Understood, sir.
This is known as the null point or the balancing length for this battery. But to get the value of this potential difference, you must know the value of x. Anyone has drawn this?
Sir.
Can I move ahead?
Wait, sir. కంప్లీటెడా వీళ్ళు సనా అయిపోయిందా కంప్లీటెడ్ సార్
Completed, sir.
సార్
Then we move on to the application of potentiometer, and the first application is to compare EMF of two cells. How I am going to compare the EMF of two cells? I am going to connect two cells to the potentiometer, to the main or primary circuit of the potentiometer.
మైక్ సౌండ్ తక్కువైంది
Do you see this diagram? I have connected two cells
సార్
to the potentiometer. Yes or no?
సార్
So first what I will do, I will put this battery in the circuit by connecting the switch like this. Point 1 will be connected to point 2. I will get a balancing length for this switch. I will move the galvanometer. I will get the null point, and then I can write the EMF E1 will be proportional to L1, the balancing length. Do we understand what I'm saying here?
ఎస్ సార్
Then what will I do? I will take this battery out, and now I will connect this battery, and again I will get the null point. I will call that null point. I will find out the length where this null point is coming. The EMF of this battery E2 will be proportional to L2. Yes or no?
సార్
I don't have to find out the potential gradient. I can simply write E1 by E2 will be equal to L1 by L2. Do we understand this?
అండర్స్టూడ్ సార్
Everyone?
సార్
Yes or no?
ఎస్ సార్
Okay, note it down quickly so that I can do the next part as well. Noted this?
డన్ సార్
Shall we move ahead?
సార్
The second function or the second application is to find out the internal resistance of the cell. Internal resistance R of this cell. Now listen to me very carefully. First of all, what is happening is I have a circuit, and this circuit is completed like this, and I look for the null point. Here only the battery is connected, and there is no current flowing through the battery. I will find out the null point in this case, and the null point in this case will correspond to the battery ka EMF E. Yes or no?
సార్
Now what I will do, I will switch this battery on. I will switch this battery on. So now current will only flow in this branch. And in this branch, the current again becomes 0 because I look for the null point. Yes or no?
Sir.
In that case, what I am getting is the potential difference across the cell. When I say across the cell, that means I am getting the potential difference between this point B and this point C, which is the potential difference across the cell V. So this V will be proportional to L2, L1, L2, E and V. And remember that revolutionary relation that I gave, E by V minus 1 into R. Do we remember that equation? To find the internal resistance of the battery, yes or no?
Sir.
I had given you this equation, yes or no? Yes or no?
Sir.
E is proportional to L1, V is proportional to L2. So the formula for finding out the internal resistance becomes L1 by L2 minus 1 into R. This R is this R, which is the external resistance connected. If you know the value of L1 and L2, which you will get by the null point, you should be able to find out the internal resistance of the battery. So it only working on the principle that as soon as you get the galvanometer current as 0, the potential difference between these 2 points will be equal to the potential gradient multiplied by length. We understand this? Everyone understands this? Every doubt regarding potentiometer is over. I have already sent you the sheet. So I hope you can solve some problems from that sheet. Can you do it on your own? Yes or no? Okay, then you can solve those problems on your own. If you have any doubts, these are the only 2 things you have to remember to compare the EMF of the battery or the cell. First, you will connect the first battery and then you will connect the second battery. The ratio of EMF will be equal to L1 by L2. Everyone has understood this? To find out the internal resistance of the battery, you will first connect the battery without external resistance. Then you will connect the battery with external resistance. Find the galvanometer 0. The internal resistance will be L1 by L2 minus 1 into R. We understand this, everyone? Okay, then I will wind off this class here. We are done with your electrical instruments, what we had to do. In the next class, we will move on to the last part of this chapter, which is charging and discharging of capacitors. So I intend to do that chapter. Tomorrow you have a 2.5-hour class, yes or no? So I intend to finish your electric current by tomorrow, and I will try to wind up your capacitors. We just have to look for 2 formulae and solve a couple of 4 or 5 questions. Once you are done with that, I can rest in peace that we have done this. So tomorrow your electric current is going to get over by all means. Don't be late in the class. What is the time for tomorrow's class? No one knows it. 12:30. So at 12:28, everyone must be there because tomorrow I won't wait for anyone. 12:30, I will start because I have to finish that part in tomorrow's class. If something left, that will spill onto the next class and it will destroy the next class as well. So 12:30 sharp, you have to be there so that by 3 I can wind up your electric current. Take care, and whatever lunch, dinner, bhaji, pulao, whatever you have to eat it at 12 o'clock. Okay, 12 o'clock eat, 12:15 have your whatever you do, and 12:30 in the class. So I'll see you tomorrow. Take care. Have a nice day, everyone. Bye bye. Everyone understood what we have done today?
Yes, sir.